Hello everyone and welcome to the lecture on linear functions. Here's the plan for the lecture. First, I will introduce you to a few formulas that you will need to know. Secondly, we will be graphing linear functions and the graphs of them will be straight lines. Finally, I will show you how to write equations for linear functions. Well, here are a few formulas that you will need to know in order to be able to operate on linear functions. The first formula is y equals mx plus b. Sometimes this formula may be written as y equals ax plus b. The second formula is ax plus by equals c. Third formula is y minus y1 equals m times x minus x1. And finally, the last formula is m equals y2 minus y1 over x2 minus x1. The first formula or formulas are called slope-intercept form. The second formula is called standard form. The third formula is called point-slope form. And finally, the very last formula with the m equal to is called slope formula. I'll talk about this equation y equals mx plus b. Here, the m and the b will turn into numbers. So an example of that could be y equals 2x plus 7 or y equals negative 7x minus 1, things like that. In the second formula, the standard form, the a, b, and c will turn into numbers. So this will be 2x plus 3y equals 6 or something like that. 12y plus 7x equals 15. Both of those are standard form. In point slope form, y1, m, and x1 will turn into numbers. So an example of a point slope form could be y minus 7 equals 1/2 x plus 12. So here in this example that I have, your y1 is a 7, your m is 1/2, and your x1 is negative 12. And it's negative 12 because for this sign here to be a plus, 12 would have to have its own negative to communicate with the negative from the formula and turn into a positive. Finally, in the slope formula, all of these will become numbers, and this formula is used to calculate slopes, which I will talk more about here in a minute. So by our agenda, our next item is to graph lines or graph linear functions. So we're gonna try to do that when we're given all the different forms of linear functions. My first few examples will be graphing equations that are given to you in this y equals mx plus b or slope-intercept form. The first example I have is y equals 1/2 x minus 2. In this equation, 1/2 is your m and negative 2 is your b. The b is always the y-intercept, and the m is always what we call a slope. Here's how you use these two items to graph the line. On the coordinate plane, first place the point that represents y-intercept on the y-axis. Our y-intercept is negative 2, so we'll place that point on our y-axis. From this point, using our slope, we will travel 1 unit up because the top of the slope is 1, and 2 units to the right because the bottom of the slope is 2. I end up at this point here. Now I'm ready to graph my line by connecting the 2 points that I created. Let's look at another example. Let's say my equation is y equals negative 2/3 plus 1. 2/3 x plus 1. In this example, positive 1 is your b, which is the y-intercept, and negative 2/3 is the slope, m. To graph this line, we'll start by placing the y-intercept on the y-axis, that's 1. From this point, we will now be traveling down 2 units because the top of the slope is negative 2. And to the right, 3 units because the bottom of the slope is 3. We ended up here at this point, and that's our second point. I'm going to connect both of them. And this is my line. Notice that the first line was increasing and the second line is decreasing. And that was due to the first line having a positive slope and the second line having a negative slope. The next few equations that I will graph will be in standard form, ax plus by equals c. And here is the first example, 3x plus y equals negative 3. In this equation, your a is positive 3, your b is 1, and your c is negative 3. These numbers don't really tell us much about the line, unlike the slope and the y-intercept. So here is how we will be graphing the lines that are given to us in standard form. The easiest way to graph a line given in standard form is to use x-intercept and y-intercept. To find the x-intercept, I will use the equation of the line given, which is 3x plus y equals negative 3, and I'll replace y inside of that equation with 0. If y is 0, the equation becomes 3x equals negative 3, and solving it for x gives me x equals negative 1. This is your x-intercept, and we can place that point on the x-axis, negative 1 on x. To find the y-intercept, we will go back to our original equation right here and replace x with 0. So now I make my x to be 0, and the equation now turns into y equals negative 3, because here 3 times 0 is 0. So all you have left is y equals negative 3. This is your y-intercept. You will place that on the y-axis and connect the 2 points. Looking at this line, while the equation didn't provide us with this information, since the line is decreasing, we can assume that the slope is negative. In fact, I can calculate the slope between the 2 points. If I wanted to travel from the red point to the blue point, I could count 3 units down. So the top of the slope would be negative 3, and 1 unit to the right, so the bottom of the slope will be 1, so the slope is negative 3. So here's another standard form. We will graph using the intercepts. To find the x-intercept, I will make my y 0, and replacing y with the 0 right here, 5 times 0 will be vanished, that's 0. So you will be left with 3x equals negative 15. Which makes my x to be negative 5. This is your x-intercept. Now I'll find the y-intercept. To find the y-intercept, I make x to be 0. And if x is 0, this means this part is gone in the equations. 3 times 0 is 0. You're left with 5 times y equals negative 15. And that makes your y a negative 3. This is your y-intercept. I'm going to go ahead and plot those points on the axis. X is negative 5 and y is negative 3, and I connect the 2 points. Here is the line. Again, it looks like the line is decreasing, so the slope is negative. If I wanted to count, this one here goes down 3 and to the right 5, so the slope m would be negative 3 over 5 if you were asked. There are a couple of special cases of lines, and those will only have one letter inside of them, either the x or the y. So if you see an equation x equals 1 or y equals negative 3, for example, all these are either vertical or horizontal. So when it's only the x, the line is vertical, and it passes through 1 on x-axis. The other one, y equals -3, that one is horizontal, and it passes through -3 on y-axis. The slope of any vertical line is undefined, and the slope of a horizontal line is always 0. So this is your vertical line. It should pass through 1. That's your vertical line. So this line is x equals 1. And this line right here is y equals -3. So find -3 on that y and create a horizontal line. So now we'll be writing equations of lines. Most of the time, the question will ask you to write the equation of the line in slope-intercept form, y equals mx plus b. Keep in mind that in this formula, m and b will need to turn into numbers, and y and x will stay as y and x. For a lot of these questions, we will also be using the formula y minus y1 equals mx minus x1. In this question, y1, m, and x are numbers, and then we'll also use the slope formula, m equals y2 minus y1 over x2 minus x1. Well, here is the first example. Now keep in mind that in these points, the first numbers are x's, so this is the x of the first point, and this is the y of the first point. And 2 for the second point is the x, and y is 5. So these little indexes that you see, the y1 and x1, that's just basically telling us that that's the x of the first point or the y of the first point, and so on. So to write the slope-intercept form, this form right here, I need the m and the b, and unfortunately I am not provided with either. All I have are these 2 random points that are on the line. However, in this formula right here, to find the slope, all I need is the x's of both points and the y's of both points. So I can at least find the m. Let's go ahead and do that. So the slope m, using our slope formula, is on top y2 minus y1. So that's 5 minus -2. Now notice that the first minus here comes from the formula, and the second minus belongs to the -2 here. And then at the bottom, I have my x2 minus x1, so that's 2 minus 1. So on the top, it's a 7, and on the bottom, it's a 1, or it's just a 7. So the slope is 7. So now that we have our slope m, which is equal to 7, the equation, this form here, can turn into y equals 7x plus b. But we still have to find b in order to satisfy the requirements, because b and m both need to become numbers. To find b, there is a couple of options. One would be to use this formula here, y minus y1 equals m, parentheses x minus x1. Replace m with the 7, x1 with this 1, and y1 with this -2, and then work on that equation. Another option would be to use this equation here and replace this y temporarily with -2 and this x temporarily with this 1, find b, and then write the equation over. I'm going to use the second option, but you can feel free to use the point slope formula option. So here is how this equation is going to look like now. The y in the front temporarily turns into -2. The x turns into this 1. And then plus b in the back stays as is. So this is -2 equals 7 plus b. To solve for b, you simply subtract the 7 from -2, and that makes your b a -9. Now we are ready to write this form with m being 7 and b being negative 9. So the answer to this question is y equals 7x minus 9. A quick remark before I move into writing a different equation for a different line. The same 2 points that I gave you as two ordered pairs, xy, xy, can be given to you in a different format. For example, this first point, 1, negative 2, can be written as f of 1 equals negative 2. And that's essentially the same thing. All you have to recognize is that x is 1 and y is negative 2. And the second point then would be f of 2 equals 5. So here's the second example. Given 2 points, the x-intercept, which is 2, and the y-intercept, which is 3, and the problem asks us to write the equation in y equals mx plus b form. So keep in mind that in this equation, m will need to become a number and b will need to become a number. M is the slope and b is the y-intercept. Well, good news is the y-intercept is actually given to us. It's 3. So right away, I can write my equation as y equals mx plus 3 because b is the y-intercept. Now I still have to find the m, and what we need to recognize here is that both the x-intercept that's given and the y-intercept that's given is actually points. The x-intercept is the point where x is 2 and y is 0, and the y-intercept is the point where x is 0 and y is 3. So what we can do is to use our slope formula, plug those numbers into the formula. So for this specific problem, your 2 here is x1, this is y1, x2, y2, and we can find the slope. So y2 is 3, y1 is 0, x2 is 0, x1 is 2. So 3 minus 0 is 3, 0 minus 2 at the bottom is negative 2, so all in all it's negative 3 over 2. And this is your slope. Now that you have the slope, you're ready to plug it into m, and you're done with the equation. Y equals negative 3 over 2 x plus 3. And here's my last example. You will be given the graph of a line. It's a decreasing line, so the slope will be negative. And you are asked to write in slope-intercept form. Technically, this question is exactly the same as the previous question because on this picture, what you see is that your line hits y-axis at 1 and x-axis at 2. So you know that the x-intercept is 2, or if you wanted to write it as a point, it would be 2, 0. And then the y-intercept is 1, and if you wanted to write that as a point, it would be 0, 1. And then the question becomes exactly the same as the previous question.